So we'll do a quick kind of run through on the equation of a line, just generally. So starting off with kind of some things that we know already. So to find the equation of a line, we need two things. We need the slope and we need a point. Okay, and that's good to kind of know off to have in your head. If I want equation, I need slope, I need point. We can then use the formula then to find the equation of the line. So that's the formula that's in your log tables. So if we're given a point and we wanted to find the equation through that point, then we just sub the point in and we get kind of a general form like this one, where m is our slope, and m obviously in this point is unknown. Then if we're given some more information, we can use that then to find the slope or to find specific lines. But it's important as well that you kind of have that in your head as well, that if I'm just given a point and not given the slope, I can still find a kind of general form for the line, and then I might have some other information later in the question that will let me find the specific slope that I'm looking for. So looking at this part, then the general form for the equation of a line is ax plus by plus c. So this form here, this is what we call our general form. And for a line written in that form, there are a few key points that you should know. This first point is really, really important. If a line is written in this form, the slope of the line is minus a over b. And it comes from rearranging the line. But in reality, when you're working through these questions, you're going to want to know that. You're going to want to know that off quickly so that you can kind of move on. So if your line is written in that form, ax plus by plus c is equal to 0, the slope will be minus a over b. It's always minus a over b. So whatever a, even if a is a minus number, then obviously that will change your slope. But your slope is minus a over b. If we're asked for a line parallel to a line like this one, ax plus by plus c, then it would be ax plus by plus k. Okay, so the only bit that's different is the last letter, the last number, of course. So that would be kind of your intercept type one. So a and b relate to the slope. If they're parallel, they'll have the same slope. So the ax and the by part will be the same. The only part that will be different is the last part. If we're looking for one that's perpendicular, that's where we change ever so slightly. Instead of it being ax plus by plus c, then the perpendicular one would be bx minus ay plus k. And what that means for us is that the slope of this one, minus a over b, the slope of this one would be minus a, so it's still kind of minus a over b in the same sense. We end up with b over a. And we know already that the slopes of two lines, if they're perpendicular, will multiply to give me minus 1. Okay, looking at the next form that I have then is my slope intercept form. And this again is one that comes up a lot at junior cycles, so it's probably the one we're most comfortable with. But again, it's y is equal to mx plus c, where m is your slope, c is your y-intercept. A line parallel will be, the mx part will be the same, the k part will be different, so it'll just cut the y-axis at a different point, so either higher or lower. A line perpendicular would be minus 1 over m plus k. Okay, so those parts, the two parts could be different. So find the equation of the line parallel to 3x minus 2y plus 4 equals 0 that goes through the point 2 minus 3. So we have two ways of doing this. So we could look for the slope of this first line, which is minus a over b, so minus 3 over minus 2, which is going to be, of course, just 3 over 2. So that's going to be the slope of my parallel line as well. My point is 2 minus 3. And then I can use my y minus y1, so y plus 3 is equal to 3 over 2 x minus 2. Y plus 3 equals 3 over 2 x minus 3. And then just kind of rearranging, reordering, writing it in the same form as the line that's given in the question. Minus y minus 6 equals 0. So 3x minus 2y minus 12 equals 0. Okay, so again, we get one parallel. We said if it's parallel, we would expect this first part to be the same, and it is. And just the last part then is different. Finding the equation of the perpendicular bisector of AB. So bisector means that it cuts it in half. Okay, so it cuts it in half, and that should ring in our head as midpoint. So we need to get the midpoint of AB. So the midpoint of AB is going to be minus 1 plus 5 over 2 and 4 minus 4 over 2, which is of course going to give me 4 over 2, 0, or 2, 0. So that's my point. Let me highlight in a different color there. So that's the point that I'm going to use. The other thing I need for equation of the line is the slope. So the slope is going to be y2 minus y1 over x2 minus x1. So minus 8 over 6. Okay, and we get then minus 4 over 3. So let's sub into our formula. Minus 4 over 3x minus 2. So y is equal to minus 4 over 3x plus 8 over 3. And we can leave it in that form. Okay, that's perfectly acceptable to leave in that form. We could also get rid of the fractions and rearrange to make it a bit nicer. And we can end up with that form there. It's the same idea. Okay. Right, let's look at an exam question then. I think we've just the one exam question here. So show that for all k real numbers, the point P lies on the given line L1. So to show that a point lies on a line, we did this in the kind of fundamental part, we have to be able to sub in and end up with the same thing on both sides, or kind of satisfy the equation. So we're subbing in for x there, and then I'll sub in the value for y as well, using our brackets. 12k minus 3 minus 12k minus 4 plus 10. So we get minus 7 plus 10. Made a mistake somewhere. Yes, I have. I took down the line wrong. There we go. That's better. So that makes more sense. Okay, and we're expecting the same thing on both sides, which is how I knew that they maybe made a little bit of a slip in taking it down. We get 0 is equal to 0, which shows us that that point is on the line. Part B then says the line L2 passes through P and is perpendicular. Find the equation of L2 in terms of K. So we have our point. So our point is P. Our slope, well, let's get the slope of L1 first. The slope of L1 minus a over b, so minus 3 over minus 4, which is 3 over 4. And that means that the slope of my L2, the perpendicular one, will be minus 4 over 3. That comes back to our rules for slopes. If they're perpendicular, the slope of one will be kind of the reciprocal and the negative reciprocal of the other one, or the inverse. Then I just use my formula. So I'm using the point P. I'm doing it in terms of K. So 3k plus 1. I'm going to use my brackets here to keep everything neat. X minus 4k minus 2. Okay, running into myself there. So y minus 3k minus 1 is equal to minus 4 over 3x. And let's see then, so we'll get, do you know what we'll do actually first is we'll multiply the in here. So minus 4k plus 2. So y minus 3k minus 1 minus 4 over 3x plus 16k over 3 minus 8 over 3. And then we'll just tidy up a little bit. Okay, we'll multiply across by 3 to get rid of those fractions, just to keep everything nice and neat, because we're probably going to have to work with these answers in the next parts. So 4x plus 3y, and then the k's, so let me see, plus 5 minus 25k equals 0. Okay, so that's my equation of the line. Find the value of k for which L2 passes through the point 311. So we're told it passes through the point 311. So this is my part C. So is that Q, is that what they call it? Yeah, 311. So we're going to sub that in. So anywhere we see x, we're going to put in 3. Anywhere we see y, we're going to see 11. And we're expecting this to be equal to 0. So 12 plus 33 plus 5 minus 25k equals 0. Let's just sort out all our number parts. So minus 25k is equal to minus 50, so k is equal to 2. Okay. Then hence or otherwise find the coordinates of the point of intersection of the perpendicular from Q to L1. So we're looking for the point of intersection of this line here. So the line from Q to L1. So we are looking for the points of intersection of this line, and this line here goes through the point Q, is perpendicular to L1, which makes it the line that we just found in the last part. So taking my 4x minus 3y plus 5 minus 50 equals 0, tidying this up, 3y minus 45 equals 0. Okay, that's going to be my first line. The other line I would need to use in my simultaneous equation to find the point of intersection will be L1, which is this one here, 3x minus 4y plus 10. So let's take this over to the side here. I really didn't give enough space for this. Just go with it. 3x minus 4y plus 10, I think. Yeah. Okay, and again, just rearranging a little bit. So we'll write it in our usual kind of simultaneous equation format. Okay. So what we need to do is we need to pick one of these sides, it doesn't matter which one, and do the same thing to both. Now I am foreseeing that we will run into some issues, so let's just again make sure, as per always, that we have everything laid out in the nicest way possible that we possibly can. We do, yeah. Yes, 4x plus 3y, there we go. See, I'm dropping pluses across the place here. 4x plus 3y, that makes a bit more sense. Work out a bit nicer for us. So let's do this one by 4, and we'll do this one by 3. Okay, so that's going to give me 16x minus 12, or sorry, plus 12y now. So plus 12y equals 45 by 4, which is 180. And 9x minus 12y is equal to minus 30. Okay, so that gives me 25x is equal to 150, and x is equal to 150 divided by 25, which gives me an answer of 6. Then I can sub back into either of these to find my value for x, or for y, sorry. 3y equals 45. 24 plus 3y equals 45, 3y equals 21, y equals 7. So my point of intersection then is 6, 7. Okay, so being careful there, I suppose, is good to make sure that we're just keeping consistent with everything as we work through it there, and that you're taking everything down. I really didn't give enough space for this part here, but anyway, we'll continue on. So the key thing there with that question really was working through kind of methodically, making sure that we know exactly what they're asking for. So finding the equation of a line that's perpendicular to another one, using your general form of the equations of the line. I suppose more generally, it's just making sure that you're happy with these few forms of the line, that you get into the habit of answering questions in these particular ways, using that kind of slope as minus a over b, rewriting the equation of a parallel line if you're given one, using like that example we had there with the mx minus y minus 5m plus 6. So that's something that comes up quite a lot in later questions. So it's just being willing to be more general with your equations of the line. They don't have to always have all the numbers figured out. Sometimes to answer the questions, you'll have to just go as far as you can in writing the equation of the line, and then there'll be something else in the question then that will give you more information.